Alright, welcome back. So this video is the continuation of just now the simple lifting machine. There's actually another lesson for simple lifting machines after the first tutorial. Okay, and the major difference between the second lesson and the first lesson is just the introduction of different kinds of simple lifting machines. Okay, and the formula for their respective velocity ratio. That is the only difference. Okay, the rest is all still the same. You still have your mechanical advantage, you still have your efficiencies, and your velocity, effort velocity, and your load velocity, etc. Okay, the main thing is to teach you the formula for the VR for the different kinds of machines. Take for example, okay, this is called a wheel and axle. Okay, so it looks like this, right? So you're supposed to pull over here, the effort is supposed to pull over here, and then this load will go up, okay, based on the amount that you pull. Okay, for designs like this, here the velocity ratio is the big D over small d. Okay, and please note the big D in this topic is always the effort diameter. Okay, the effort diameter is where the effort is being applied. Okay, so big D, small d is always the load diameter. Okay, one thing I want to bring to notice is sometimes this big D is not expressed in a pulley wheel. Okay, it might be a handle. Okay, for example, if I draw it this way, okay, you have a handle like this. Okay, I'm just drawing 3D. You have a handle like this, right? And then you are actually applying the effort at this part of the handle. Am I right? So so that when you make one turn, how does it look like? It looks like this, correct? So the big D in this case is this circle that is formed. Okay, is the diameter of this circle that is formed. If this length is L, this length of the handle is L, then big D will then be 2L. Okay, so just to take note, and not every time the effort takes place in a wheel, it can be a handle. Okay, then your big D you need to know how to find. All right. Another example, a very typical example, is the gear train. Okay, gear train. The formula is like this. You have a driver and a follower. So the gear ratio for this case will be the number of teeth of the follower over the number of teeth over the driver. Okay, 2 over 1, N2 over N1. Okay, and for the for the crab winch, a typical crab winch looking like this. Okay, from the effort side to the load side. Okay, effort side starts from gear 1, which is connected to gear 2 and gear 3, and then this gear 3 is connected to the gear 4 on the load side. Okay, and then your effort drum will be this diameter, and the load drum will be from this diameter here. Okay, and the 1, 2, 3, 4 is like this. Okay, so having established this numbering, your velocity ratio is then this formula. Okay, N2 over N1 times N4 over N3, big D over small d. The naming is the same across the board. All right. So when the question asks you for gear ratio, what is the gear ratio, then your formula will be your answer should be this one. Okay, which is N2 over N1 times N4 over N3. This would be your gear ratio. Okay, so this is actually gear ratio times big D over small d. Okay. Okay, then there is a worm and worm differential, wheel and axle, worm and worm wheel, and a few others lah. All right, I'll leave it to you to go through. I will now then talk about the last tutorial. Last question in the tutorial. Okay, this question here. Okay. Okay, so it is a crab winch, very straightforward. It's a crab winch, and then diameter at the effort and the load side. Okay, which means this is question 4.9. Diameter at the load side, effort side is 0.18 meters, which is 180 mm. Okay, and the small d would be 0.08 meters. Okay, because it is 80 mm. Velocity ratio is given 18. Okay. Now the question asks you to find law of the machine. Okay, giving you 2 points. E1 is 108.29. W1 is, see, this is where the mass is given instead of newtons. So you have to multiply by 9.81. Okay, and then the efforts, the second effort is 284.87. Second load is 450 kilogram. Okay, times 9.81. Okay, I will leave you to do the simultaneous equation. You should get A is 0.06, B is 20. Okay, so E is equals to 0.06 W plus 20. Okay. B, the actual effort, friction effort, MA, and efficiency in lifting a load of 250 kilogram. Okay, so you multiply by 9.81. This is 2452.5 Newton. Okay, then you substitute into the law of the machine. Okay, you will get 167.15 Newton. Okay, you can also find your ideal effort, which is W over VR, sorry, W over VR. So W is this, 2452.5, VR is 18, given. Okay, so you get 136.25 Newton. Okay, the effort is this, so the friction effort is this minus this. Okay, E minus ideal. So this will give you 30.9 Newton. Usually friction effort is quite small. It will be the smallest among the 3 E's. Okay. Okay. And with this, we can find our MA. Okay, W over E. Okay, W over E. So this will give you 14.67. All right. Efficiency will be, after you find MA, you can find efficiency. Okay, you should get 0.815, which is 81.5%. Okay, so the sequence is like W, find E, find EI, find EF, find MA, and finally you can find efficiency. Okay. Okay, again, the power required. All right, the required means required from you. How much effort are you supposed to put in? So the power is the power input. Okay, the input side is the effort side, which means you need to multiply effort with effort velocity. Okay, force times velocity. Okay, and again, they will never give you VE. They will tell you that the load needs to move at a certain speed. Okay, in this case it's 125 mm per second, which is 0.125 meters per second. Okay, the load is just now the load. Okay, the same. W is 2452.5 because it's 250 kilogram. So with the formula, VR is equals to VE over VW. Therefore, VE is 18 times 0.125. Okay, 2.25 meter per second. So usually the velocity at the effort side will be much faster than the load side. Okay, if you have done your experiment, you should know when you do the crab winch, you need to move very fast, but the load climb up slower, much slower. Okay, so the power input is your effort 167.15 times this velocity. Okay, 2.25, 367.09 watts. Okay, and the gear ratio. This one is playing with using the formula for the crab winch. You know, velocity ratio is gear ratio times effort drop diameter over load diameter. Okay, and we actually have these two. Okay, so gear ratio is just VR times load over effort. Okay, 18 times 80 over 180. Okay, so you will get 8. Okay, gear ratio is 8.